Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Velocity DVSL is a specialized extension of the Apache Velocity template engine, designed specifically for working with XML data. It allows developers to transform XML documents using Velocity templates, making it easier to generate dynamic XML outputs. This tool is especially useful in enterprise environments where structured document generation is a common requirement. DVSL simplifies XML transformations by combining the power of Velocity's templating with XML-aware directives. DVSL is a powerful choice when you need to perform XML transformations programmatically. Unlike XSLT, which is XML-based itself, DVSL uses the Velocity syntax, which many developers find more intuitive. This makes it a great tool for teams already familiar with Velocity. It's also highly efficient for batch processing tasks, especially in Java environments where Velocity is already in use. At its core, DVSL relies on the document object model DOM to parse XML inputs. It then applies Velocity templates to manipulate and transform this data. You can define custom directives and macros to encapsulate reusable logic. The output can be XML, HTML, or even plain text, making DVSL flexible for a variety of document generation tasks. The architecture of DVSL follows a clear pipeline. First, an XML input is parsed into a DOM structure. Then, Velocity templates enhanced with DVSL-specific directives are applied to transform the data. Finally, the transformed data is rendered into the desired output format, whether that's XML, HTML, or plain text. This modular architecture allows for both flexibility and performance. DVSL inherits the familiar Velocity syntax, making it easy for developers to pick up. It also introduces XML-specific directives for navigating and manipulating DOM elements. You can use standard Velocity features like conditionals, loops, and macros. This combination allows for powerful, readable templates that can handle complex XML transformations. In DVSL, working with XML nodes is straightforward. You can access child nodes using methods like $node.getChild and iterate through node lists with the #forh directive. DVSL supports an XPath-like syntax for navigating the DOM tree, allowing you to target specific elements with ease. Extracting attributes and text content is also simple, making it easy to pull out the data you need. Let's walk through a basic example of transforming an XML document using DVSL. First, we load the XML into a DOM structure. Then, we apply a Velocity template that specifies how to transform the data. Finally, we render the transformed output. This approach is reusable across similar documents, making it ideal for batch processing workflows. DVSL extends Velocity with advanced directives tailored for XML. You can use #forh to iterate over XML node lists, #if for conditional rendering, and #macro to define reusable logic blocks. Additionally, you can create custom directives to handle domain-specific tasks, giving you full control over how your XML is transformed. When working with DVSL, performance is key. It's efficient for DOM-based processing, especially when templates are cached. However, deep recursion in templates can slow things down. For large XML files, consider using streaming techniques to reduce memory usage and improve speed. How does DVSL compare to XSLT? XSLT is XML native and powerful for complex transformations, but DVSL uses the familiar Velocity syntax, making it easier for many developers. While XSLT excels in complex XML manipulations, DVSL is faster and simpler for templated outputs. Your choice depends on your team's familiarity and transformation requirements. Let's look at a real-world use case, automated XML report generation. DVSL can pull data from databases, apply a velocity template, and generate formatted XML reports. This is especially useful in enterprise environments where consistency and automation are key. Templates ensure that all reports follow the same format, while batch processing saves time and reduces errors. Integrating DVSL into Java applications is straightforward. You start by using the Velocity engine enhanced with DVSL extensions. XML data is loaded into a DOM structure using Java libraries. Then, you apply templates using a DVSL context object. Finally, the rendered output can be written to a file or streamed directly to a client. To get the most out of DVSL, follow these best practices. Keep your templates simple and modular for easier maintenance. Use macros to encapsulate reusable logic. Cache parse templates to improve performance, especially in batch processing scenarios. Always validate XML inputs to avoid runtime errors and ensure data integrity. Even with its power, DVSL has some common pitfalls. Avoid deeply nested templates that are hard to debug. Don't hardcode values, use variables instead. Handle null values gracefully to prevent runtime errors. And always use logging to trace template execution and identify issues quickly. Debugging DVSL templates can be tricky if you don't know where to look. Start by enabling logging to trace template execution. Validate the XML structure before processing to catch structural issues early. Test templates with sample data to ensure they behave as expected. Finally, double-check velocity syntax for any errors that could break rendering. In enterprise systems, DVSL shines in automated document generation. It integrates well with legacy systems and supports batch processing workflows. It's also ideal for regulatory compliance reporting, where structured, consistent documents are required. Its ability to transform data into standardized formats makes it a valuable tool for enterprise automation. You can extend DVSL by creating custom directives tailored to your domain. These directives can encapsulate complex operations, making templates cleaner and more maintainable. By building reusable components, you improve both clarity and efficiency. This customization is one of DVSL's strongest features, allowing it to adapt to your specific needs. Caching parsed templates is a key performance optimization in DVSL. It reduces overhead in batch processing scenarios and improves response time in web applications. Velocity provides built-in caching features that you can leverage. By caching templates, you ensure that repeated transformations are faster and more efficient. Handling large XML files requires a different approach. Instead of loading the entire DOM into memory, use streaming parsers. Break transformations into smaller steps to reduce memory usage. Optimize templates to minimize processing overhead. These techniques ensure that DVSL remains efficient even with large datasets. DVSL fits well into microservices architectures. It's ideal for lightweight transformation services and integrates smoothly with REST APIs. You can use it to convert JSON data into XML or vice versa. Plus, DVSL services can be containerized for easy scaling and deployment in cloud environments. Security is critical when using DVSL in production. Always validate XML inputs to prevent injection attacks. Sanitize data before processing to avoid malicious payloads. Never execute untrusted templates, and follow secure coding practices throughout your implementation. These steps help protect your systems from potential vulnerabilities. DVSL is a great fit for DevOps pipelines. It can automate XML configuration generation, integrate with CI/CD tools, and generate deployment manifests. It supports infrastructure as code workflows by transforming metadata into structured configuration files. This makes it a valuable tool for modern DevOps practices. Let's look at a case study where DVSL was used to automate quarterly financial reports. Templates ensured consistent formatting across all reports. Data was batch processed from internal databases. The result? An 80% reduction in manual effort and faster, error-free report generation. This is a great example of DVSL real-world impact. How does DVSL compare to other template engines? It's more XML-focused than general-purpose engines like ThymeLeaf. It's simpler than XSLT for basic transformations. It integrates better with Java than engines like Jinja 2. However, it has less community support than Velocity alone, which can be a limitation. What does the future hold for DVSL? There's potential for enhanced streaming support and better integration with modern frameworks. Improved documentation and tooling could make it more accessible. While adoption is currently niche, DVSL unique strengths could lead to growing interest in specialized domains like financial reporting and enterprise automation. Ready to dive deeper into DVSL? Start with the Apache Velocity documentation, which covers the core concepts. Look for DVSL tutorials on GitHub and explore community forums on Stack Overflow. Hands-on practice with sample projects will solidify your understanding. These resources will help you master DVSL and apply it effectively in your projects. Getting started with DVSL is easy. First, install Apache Velocity with DVSL extensions. Set up a Java project using Maven or Gradle. Create a simple XML template and run your first transformation. This hands-on approach will give you a solid foundation to build on as you explore more advanced features. DVSL is used in some legacy enterprise tools and has a small but dedicated open-source community. While active development is limited, it's still a good tool for learning templating concepts. Its niche status means fewer updates, but its core functionality remains solid for XML transformations. DVSL is designed for XML, not JSON. For JSON templating, tools like Handlebars or Mustache are better choices. However, DVSL can convert JSON data into XML if needed. The key is to choose the right tool based on your data format and transformation needs. DVSL performs well for DOM-based transformations, especially when templates are cached. Streaming techniques can reduce memory usage for large files. To evaluate performance, benchmark DVSL against XSLT using your specific data. This will help you choose the best tool for your use case. Effective error handling is crucial in DVSL. Catch parsing errors early by validating XML inputs. Use try-catch blocks in Java to handle runtime exceptions. Log errors to aid debugging and validate templates before deployment. These practices ensure robust and reliable transformations. DVSL works well in cloud environments. It can be containerized for scalability and is ideal for serverless transformation tasks. Integration with cloud storage services allows for seamless data processing. Auto-scaling workflows can be implemented to handle variable loads efficiently. The DVSL community is relatively small, but resources are available. Apache Velocity forums offer support, and GitHub repositories provide examples. Stack Overflow is a good place to troubleshoot issues. While not as active as other tools, the community is helpful for niche use cases. DVSL excels in legacy systems that rely heavily on XML. It can modernize report generation workflows and integrates well with older Java versions. By automating data processing, DVSL reduces manual effort and improves efficiency in legacy environments. Testing DVSL templates is essential for reliability. Unit test templates with sample data and mock XML inputs for edge cases. Validate outputs against schemas to ensure correctness. Automate tests in CI pipelines to catch issues early. These strategies ensure robust and error-free transformations. The DVSL roadmap focuses on performance enhancements and better streaming support. Improved documentation and examples are also in the works. Community-driven feature requests help guide development. While not actively developed, DVSL continues to evolve based on user needs. Apache Velocity DVSL is a powerful tool for XML transformations, especially in Java-based systems. It's ideal for report generation, automation, and structured document workflows. While it may not be mainstream, its niche capabilities make it invaluable for the right use cases. If you found this tutorial helpful, don't forget to like, subscribe, and share your thoughts in the comments. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.